FAPI really started back at the very beginning of the small cell market, or the femto market then, and it really came about because the market started as a collection of small companies. And so traditionally you would put a small cell together from a collection of components from different companies, and FAPI provides the interfaces to those. So by having that interchangeable set of parts, we get that kind of healthy ecosystem. And those small companies also find it beneficial to kind of collaborate together and develop those APIs, as it's quite technical work to do, and that collaboration really makes that work simpler. It did take a while for FAPI to become adopted, and really over 10 years ago that we first publicly released the first LT API, and it took quite a long period of time for that to gradually be adopted as companies realized they didn't have to redo work. Myself, I was quite fortunate because I work for a small startup, PicoChip, and we were very happy to help donate towards the API. So a lot of that initial work with FAPI is very much that the small companies who were involved in the market realised that by collaborating together and submitting contributions to the API, we increase the overall size of the market. And if we've got a healthy small cell ecosystem and it grows and gets bigger, then for the companies involved, that's just got to be a good thing. I think we've moved from LTE to 5G as the industry's moved to 5G, but the same drivers still exist. It's the fact that small cells are an inherent part of 5G, but they are still growing as a market and still making that market healthy is good. And I think companies really saw that the LTE FAPI was quality, it supported, it got evolved, and so by actually collaborating and doing that for 5G, we are again helping everyone along to get those 5G small cells out there as quickly as possible. To the transition from 4G to 5G from the API perspective, the complexity is that 5G is so much more flexible. In LTE there were restrictions on TDD, there were certain TDD frame patterns, we can have whatever we want in 5G. We've got the increase up to different bands, some millimeter wave, sub 6 gigahertz. Beamforming is a huge part of 5G, and beamforming is an entirely physical air feature, so that's obviously something we need to make sure that we're enabling when we do the API, and that we can let people innovate in that area. So as the complexity of 5G's grown over 4G, that means that our API has to become more complex as well. One of the drivers of FAPI has always been about allowing people to innovate and allowing innovation to be successful. And so we need to make sure that we kind of allow that innovation within FAPI. So a lot of what companies might build to start with might only be a small set of features, but right from the start we need FAPI to support pretty much everything, so that when that innovation is done, that FAPI is there and ready and isn't a hindrance but actually going to help that. So I think openness to the API is really critical, so that it's the innovation within the market that makes the market successful. For new entrants that are coming in, then we can remove barriers by having an API that they can adopt, and then if they have an innovative product, it can be successful, and it's really that's what we want to be the reason why someone is successful in the market, their innovation, not that they've got a sort of proprietary lock-in, and that's what openness in the API gives us. We've got the extra data that we're needing to have to carry across our network going forwards, and then we have all these extra new vertical segments, and a lot of that way making a cost-effective network is having like the openness of APIs, NFV with splits between separation of hardware and software. It all really just enables a better ecosystem from a cost-effective perspective, and is